Good morning, and I do apologize that I wasn't able to make it onto campus. That is totally my fault. Right, we're just going to be finishing up derivatives of vector functions, right? Right, so we're given a vector and we want to find several values for it. So we're going to start with the derivative of r with respect to t. And we'll do that. Okay. This power cord isn't working, so just give me a minute so I can plug my tablet in. Okay, there we go. That should hopefully stay plugged in now. And so remember that to find the derivative of a vector, right, it is the derivative of each component. And so the derivative of 3 cosine, negative 3 sine. The derivative of 3 sine was 3 cosine of t. Derivative of 4t is just 4. And so there is our derivative. This isn't going to work. Okay, so there. Now that should work. right, now we want the second derivative. Okay. So just as with real valued functions, right? The second derivative of a vector valued function is just the derivative of the derivative. So what we want is the derivative of part A that we just found. Okay. So derivative, -3 sine, -3 cosine. Derivative of 3 cosine is -3 sine, and the derivative of 4 is 0. So that would be our second derivative. Okay, and if you could just excuse me for a minute. Okay, sorry about that. All right, now we're being asked to find the magnitude of that derivative we just found. So the magnitude of the derivative from part A. It's the square root of 9 sine squared plus 9 cosine squared plus 16. Right? And of course, notice we have a 9 sine squared plus 9 cosine squared. That would just be 9. We're left with 9 plus 16, which is 5. And this just leaves us with one part left to do. Now with the magnitude of the second derivative. Oops, sorry, not 3. So this is just the square root of 9 cosine squared plus 9 sine squared. Again, the cosine squared plus sine squared is 1, so that's just 9 times 1. Root 9 is 3. So now we're given two vectors. We're going to find these two derivatives. We'll start with, of course, part A. Now, as was mentioned yesterday, we don't actually have to use the cross product rule. Which is this. And we don't really need that. Because we can just find u cross v first and then take the derivative of that, which is how I'm going to proceed. Now what we're going to do is rewrite v since v is only given two components, we can write it as a 3 vector, right? Just by making that third component 0. Right now, what we'll get here as u cross v is negative t cubed cosine of t, negative t cubed sine of t, and negative 5t squared cosine of t minus t sine of t. All right, redo this by hand. Remember, we're taking derivative of each component. All right, and if we start the first component, that's going to require a product rule. So derivative of cosine, negative sine, times the negative t cubed, plus the derivative of the negative t cubed times cosine. Right, we'll do the same thing for the second term. That is again product rule. And then the third term, we're going to have to do 2 product rules, right? I think what I'll do is I'll write it on a new line. As such, and there would be our derivative. That can be simplified. Just for the sake of space, that would be negative 11t cosine of t. All right, next up. The derivative of u dot u, but you take any vector dot itself, it's just the magnitude of it squared. Right, so this is actually what we're looking for. Right now, u squared 25t to the 4th plus t squared plus t to the 6th. And so what we wind up with is 100t cubed plus 2t plus 6t to the 5th. And let's just rewrite that in descending order of power. All right, we're going to show this. All right, so we're going to say let u be u1, u2, u3, where each of those u1, u2, u3 are differentiable functions of t. Then the magnitude of u, square root of u1 squared plus u2 squared plus u3 squared, which means if we take its derivative, then we have to do chain rule. I'm going to use prime notation. All right, notice that each of these terms here has a 2, so we can factor it out. It's going to cancel out with the 1/2. Move this to the denominator as a square root. Now, if you look at that numerator, that is just a dot product. This is what we wind up with. And therefore, what we find is we multiply now by u. We get our result. Oops. Evaluate this integral. Now again, remember, that when evaluating the integral of a vector, what we're actually doing is integrating each component. Now we can just apply fundamental theorem of calculus. Okay, that's 3t from t equals 1 to 2. Then it's t to the 4th over 4 plus t to the 8th over 2. That is from 1 to 2. And t squared over 2, again, from 1 to 2. First component, we just get 3 times 1. For the second component, if we look here, that is, let's actually use my mouse. All right, so I'm looking at this term here. That is 2 to the 4th. 16 minus 1 is 15. All right, so that's 15 over 4. Here we have 2 to the 8th, which is 256. Minus 1 is 255 over 2. Then when we add the two terms, you should find 525 over 4. All right, and then for that last term, 2 squared is 4, minus 1 is 3. 3 halves. That would be the integral. And we got one more. Can evaluate this antiderivative. What we're going to do is notice first that if we take a look at the derivative of v cross v dot, all right, and v dot just means, again, remember the derivative of v with respect to time. Right, that is v dot cross v dot plus v dot, v cross v double dot. Any vector cross itself is 0. So that's just the 0 vector. And if you add the 0 vector to a vector, nothing happens. So we're left with v cross the second derivative of v with respect to time. Our antiderivative then becomes the antiderivative of d dt, v cross dv dt, dt, and that is just v cross dv dt plus some constant vector. Okay. And I just, of course, noticed that none of these had their own symbol, but yeah, whatever. I'll fix that later. Okay, so as a reminder, you do have the discussion 2 responses being due on the 17th. That is Monday night. You have 2 WebAssign homeworks. One will be due Thursday. One will be due next Friday. Of course, you have the second project. Continue working on that. And the first exam is Friday. Okay. So again, I do apologize that I wasn't able to make it onto campus. I will be posting this screen share very shortly and then message you on Teams when it is available. Enjoy the rest of your weekend. I will see everyone on... Oh, actually, I will not see you on Tuesday. I do have a prior appointment on Tuesday in the morning, so I will not be able to make it to class. I will post these slides ahead of time. So on Tuesday, just look at those slides, especially the definitions. Try to do the questions on your own. On Thursday, I will just go over those questions. I won't go over the introductory slides like I would normally do, right? The definitions and theorems and all that. I'll just jump right into the problems on Thursday. And if I can't finish the problems on Thursday, I'll just post the recording on curvature and arc length from last semester's Calc 3. So I will see everyone Thursday